Hey everybody! So today we're going to do a workshop about Oasis Sapphire for the Privacy for Web3 hackathon. I'm going to walk you through what is Oasis Sapphire, what's confidential EVM, how do we deploy contracts onto Sapphire using the normal sort of Web3 tools like Hardhat and Ethers and VS Code. Then I'm going to run through a couple of interesting examples and use cases, and then maybe we'll explore a couple of interesting different concepts here. So let's start off with confidential EVM. It's for privacy, it's for AI, and probably a lot more. So I do think that Oasis Sapphire is the next generation of EVM compatible chains. And why is it the next generation? That's an interesting question. And where does privacy, where does AI sit into all of this? And well, I think it's good to start off with some really basic questions. Why do we need privacy? Is confidentiality the same? So I always refer back to the real world. 90% of the real world with business, with regulations, with just the interactions we have with each other, it's not fully transparent, it's not fully private, and we all live somewhere in between of these where we want to have some things that are public and transparent, such as my Facebook posts, or the address on the front of an envelope when I'm trying to send a letter. But also I want privacy, so my private messages between people, I want those to be private. The contents of the envelope that I'm sending, I want that to be private. But we have to enforce this in some way. And Ethereum, there's a huge ecosystem around Ethereum with everything's transparent, but fundamentally that's really, really limiting. So there's some sort of hard limits on what we can do. And with Oasis Sapphire, what we're trying to do is to allow you to develop smart contracts that allow you to choose what is private, what is transparent on a case by case basis or an app by app basis, so that you can be in the real world. You can develop applications that do things that are realistic, rather than having to force yourself into like a fully transparent situation or trying to make everything private, right? So yeah, let's get into a confidential EVM. So we all know Ethereum. Ethereum's great. It allows composability. It allows flexibility. You've got speed, so you can do lots of different transactions across the world a lot quicker than you can do with regular banks. But it doesn't have privacy, and it doesn't necessarily have autonomy. So if we wanted to add privacy to Ethereum, it becomes very complicated very quickly. You can have like privacy coins, or you can have privacy protocols, or you can go into zero knowledge and multi-party computation, but it's not what Ethereum does by default. So you have to add it on, and it becomes very complicated because of the math and stuff that's involved there. But if we wanted to make a twist to Ethereum, what if we said we wanted to have confidentiality, privacy, and autonomy by default with Ethereum? Well, you can't do it on Ethereum, so we had to make Oasis Sapphire. So with Oasis Sapphire, it's running in a trusted execution environment. So it's just like EVM and the Ethereum virtual machine, but you get privacy by default, and you also get privacy. So um, privacy and autonomy rather. So with autonomy, that means that you can have smart contracts that can act on their own on other chains if you want them to, which means you might not have to have bridges there. So anyway, let's cover very quickly how does confidential EVM work. So with a confidential EVM, you have end-to-end encryption between the dApp that runs in your browser and the smart contract. So the call data is encrypted. All of the contract storage is also encrypted. So we have the confidential EVM that runs in the trusted execution environment, which is helped by the Oasis Paratime SDK. We have a key manager here. So the key manager runs in a segregated trusted execution environment that's separate from Sapphire, which this means that when it's running in the trusted execution environment, all of the runtime state is encrypted. The key manager provides Sapphire with a limited subset of the keys necessary for it to decrypt the contract storage, which means that we have a confidential Ethereum virtual machine with encrypted runtime execution and encrypted contract state, which means that none of the node operators themselves can see what's going on. If you look at the block explorer, you can't see the content of the transactions, which means you get things like MEV protection for free. So if I can't see what the transaction call data is, I can't anticipate what you're going to do and jump in and front run you, for example. A side benefit of this is because everything's running in a trust execution environment, we have verifiable encryption. So not just the software is verifiable, but because you're talking with the trust execution environment through an encrypted channel, that means you can be guaranteed that you're talking with the real smart contract with verifiable software, verifiable deployments, and so on and so forth. Versus if you were to make an RPC request to Ethereum and you ask what the price of Bitcoin is on Uniswap, the question there is how do you know that the response you get from the RPC provider is the real response? So with a confidential EVM, because we have end-to-end encryption, because you can be assured that you're talking to a real contract within the trust execution environments, that means that you have verifiable end-to-end requests, responses, and so on and so forth. So what can we do with confidential EVM? So a lot of things are quite difficult with Ethereum. One of those is if you want to do private voting and governance, there are a lot of different situations where you might not necessarily want to show exactly what you're voting for or who voted for what. And again, back into the real world, when you go and vote in real life in the elections, um, you don't publicize who you voted for. You don't submit your vote in public. You, in private, submit your vote. They're tallied, they're counted, and with a confidential EVM, that means you can have a contract that in private, you submit your encrypted vote to it, it counts the votes, and then at the end of it, it provides the ultimate result. And throughout the entire process, it's encrypted, it's verifiable, and so on and so forth. You can also have shielded tokens with privacy. So on Ethereum, if you emit an event, everybody can see that you made a transfer. But on a confidential EVM, you can have transfers that are from person to person without emitting events. That means that nobody can see what the transfers are. You can also do key management. You can create key pairs. You have a on-chain random number generator. You can sign transactions. But if we get into more interesting cases like prediction markets, you can submit what your prediction is going to be through some AI model that you're running. You can put your prediction on chain, and nobody knows what your prediction is apart from the contract. So in the case of one of our partners, which is Ocean Protocol, we have the Predictor protocol. You submit your predictions, and if you're correct, then you get rewarded. but nobody else can see what your predictions are until the point in the future where we judge whether they're correct or not. And of course, GDPR compliance, it's a real difficult problem in the real world to put everybody's data on chain. You know, if you want to do business, you have to be very, very careful about privacy, especially in the EU, and you want to make sure that all of your users' data is protected. The best way to protect yourself from that is to not collect user data. The second best way is to interact with a blockchain such as Oasis Sapphire, where user data is processed in private and you never have to touch the data itself. You never get to see the data. And that means that you can be compliant while using Oasis Sapphire because you don't have the possibility of leaking the data because it's all managed by smart contracts. So if we have a quick look first, we have the playgrounds.oasis.io. There's lots of really interesting apps and ideas. So we can go to the playground here. We've got like a decentralized two-factor authentication where you can put in your TOTP codes into an app. We've got like authentication, a blockchain of things. We've got like confidential quizzes and voting. We've got end-to-end encryptions with proxy. We've got like a gaming demo. And at the end of the day, if you're making something and making an app, you can either start at the playground. We've got lots of GitHub links where you can fork projects. These are a variety of different front ends, so React, WAGMI, Ethers, Vue, etc., and they'll get you up to speed very, very quickly. Or when you're done with your hackathon project, we can submit them here, and you can be part of the playground collection. So yeah, let's get started with Sapphire. So can we deploy a contract in 10 minutes? So this is like a quick challenge for me. I'm kind of a little bit prepared, but first let's get some tokens for testnet. So I want to deploy a contract in 10 minutes on Oasis Sapphire. Here's the Oasis testnet explorer, and we can see there's a bunch of different transactions here, but I want to get some tokens. So to get some tokens for testnet, let's click on Sapphire here, and then in my browser, I've got my MetaMask. I can switch to an account here, put my address in. Oops. And I have to perform a captcha to make sure that I'm not a robot. I'm not sure why we have this. And within a minute or so, I'm going to have some tokens in my wallet so I can continue onwards and start deploying my contract. So I've gone through that. I'll have some tokens in a minute. The next thing to start off with is the documentation. So I need to add MetaMask to my browser. So of course I've got this set up already. I've got MetaMask. I've got Oasis Sapphire testnet here. But if I wanted to set it up from scratch, I can go open this up. I go into create a dApp, go into Sapphire, go into network. So let's go into create a dApp, go into Sapphire, go into network information, and then I've got a little button here where I can add to MetaMask, and this will add this into MetaMask here and add the network there. So the next step is we're going to walk through an example of how do I deploy a contract and then interact with it. So at the moment, one of the most popular frameworks is Hardhat. So first, we're going to add Sapphire testnet to Hardhat. We're going to go create a contract. I've already made one very quickly, but we'll create a contract, then create a deployment script. We'll go and deploy the contract, and I'll show you the contract on the Explorer. Then we'll go through and verify the contract. Then I'm going to interact with the contract, and I'll show you the difference between encrypted transactions and non-encrypted transactions on the Explorer. Then, of course, we have a bunch of different plugins. One of those is the Sapphire Hard Hat plugin. That will allow me to make encrypted transactions through Sapphire Hard Hat or through Hard Hat, and I'll show you the results on the Explorer. So if I move over to my window here, so some Slack notifications going on, and I've got my terminal here as well. Maybe I'll put those over the other way around. So I've got my basic contract set up here. So I made a contract. We're going to emit an event, and the event is going to show who called, who's the transaction creator. I also have my test script here, which we, using Hard Hat, we go and deploy the contract, wait for it to be deployed, and then we run a test case which makes sure that it works. So in Hard Hat, the first thing that we need to do is to add Hard Hat into the configuration here. So in networks, we go and add this in here. So we've got testnet.sapphire.oasis.io, and we can use the private key from the environment to for the chain that we, the key pair that we submit transactions from. So we've got that here. So I guess we should go and create a key pair here. So let's create a secret key, and you go, so set the private key here. And then next we want to try and deploy this, but first it would be good to know what's the address that we have to top up with gas. So if we go to ethers.get signers, okay, so now with my example project here, I can do pl Hard Hat. Well, we can run this without Sapphire localnet. So if I just do this normally and run it, and oh, I made a small problem there. I need to go and fix that. Sorry. Yeah, the demo gods are reminding me to do more preparation. So there we go. We've run the contract. It deploys. You've got my owner account here, so it's the default Hard Hat account there. We've deployed the contract, and then sorry, I'm just going to close my Slack. Then we've interacted with the contract. We've got the response, and so on and so forth. If we wait for the promise here, and then I do network Sapphire localnet. So here it will show me, oops, oh, testnet rather. So I'm going to do testnet. So here it will show me my account address for that randomly generated thing. So I can go into the faucet again. I can go to Sapphire, put my account address in there, verify that I'm not a robot yet again. There's a motorcycle. That's a crosswalk. Apparently I'm a robot. There we go. Okay, so if I go back and look at my address here, then I go to explorer.oasis.io. I select testnet, click on Sapphire. I put my address in here, and ta-da! It's worked. I've been given some testnet tokens from our faucet. Now, when you deploy on the testnet, it is going to take a little bit longer than when you normally deploy with Hardhat LocalNet, right? So let's go through the deployment process here. On testnet, we've got the account owner here, and the block time on Sapphire, both mainnet and testnet, it's about 6 seconds. But because we have instant finality after the block is mined, that means that as soon as the transaction is confirmed, you can consider it finalized. Versus if you look at Ethereum, where it may take 15 minutes or possibly 75 confirmations, or on Polygon it may take several hundred confirmations. We have a very low finality time here. So anyway, we've got the address of our contracts here. If I look back at the Explorer, I can see that none of these transactions are encrypted. So we have little gray lock icons here, but you can see I've created a contract, and then I've interacted with a contract from my account, and it's cost us 0.16 gas, etc. 0.016. So if I want to then go and verify the contract, so let's go to the contract address here. And you can see on the Explorer, it's not verified. And of course, if we're participating in a hackathon, we're deploying contracts onto testnet, we want to verify that the contract source code is available and it matches what is deployed on testnet. Now, rather than Etherscan or Polygon Scan or these other services, we use a service called Sourcify, which works across all of the different chains here. So if I open up Sourcify, I'm going to very quickly verify the contract. You can see it's not verified. Let's go and open up the artifact build info directory. And we've got our JSON file here. So I click in verify contract. I go and drag this JSON file over here. And the contract, which is the dorp contract, we need to give it the address. So we have the address that it was deployed at. I printed it out here. So of course, in the deployment script, it prints out the address here. So take the address, put it in here, and then we need to select the Sapphire testnet chain from this. When we submit that, along with the build file, then it will say successfully verified. It's a perfect verification. That means the build files exactly match what is deployed on chain, and we get a nice green checkbox icon. So it will take sometimes a couple of minutes for the Explorer to update, but eventually this will turn from red to a nice green color and show that everything's verified, it's deployed, etc., etc. So the next question is, how do we turn these gray icons to green icons? So we want to enable transaction encryption. So if we're trying to do private smart contracts, we want to be able to send secret information to the contracts that nobody can see on the Block Explorer. So the way to do this is we need to add the Sapphire Hardhat package to our Hardhat project. So if I do add-c Oasis protocol / Sapphire. If we go and add this to our Hardhat project, it'll take a couple of seconds depending on your internet connection. And then in our Hardhat config, we just import Oasis protocol Sapphire Hardhat. And then if we run through the deployment again, so we're going to deploy and then interact with the contract one more time. So the same owner account, it's going to give us a new contract address. In about 6 seconds, usually. There we go. So we take this contract address here. I can go back to my accounts on the Explorer, and you can see uh, by adding the sometimes the Explorer does take a couple of seconds to keep updated with the blockchain, but you can see we've made an encrypted contract deployment, and then we've interacted with the contract with encryption. So if we go and look into this transaction, you can see that the call data is encrypted. So I can't see the parameters that are being sent to the contract when I invoke it. And this is one of the fundamental basics of how we do encrypted contracts and end-to-end encryption on Oasis Sapphire. So I'm going to wrap that up quickly. We've been through how to set up Sapphire testnet and the hard hat config, how to create a contract, how to create a deployment script, view the encrypted and unencrypted transactions in the Explorer. Then we add the Sapphire hard hat plugin to hard hat, and we can see that that encrypts the transactions. So if we want to get into encrypted smart contracts, so there's a couple of really key things to understand. So the contract source code is, or the bytecode that's compiled to when you deploy it, it's not encrypted. So anybody can use like the ETH get code RPC call or the X code copy opcode to retrieve the contract bytecode. So if you went and put a password into your smart contract like this, don't do this, because I'll be able to get the passcode out, or some hacker's going to be able to get the passcode out of that and exploit your contract. The second part, though, is that as if you put like a password in your constructor when you're deploying the contract, or if you encrypt the deployment transactions, that means we won't be able to verify the contract on Sourcify. So if we go back to the Explorer here, I can see that my deployment transaction was encrypted. That means the Sourcify contract verifier won't be able to decrypt the arguments. So you need to deploy your contracts in an unencrypted way, and then in future you can interact with them in an encrypted fashion. So the next thing is, so transaction encryption. Transactions aren't encrypted by default unless you use one of the wrappers. So the wrapper is just a little layer that adds encryption. So if we want to encrypt the call data for transactions, or if we want to encrypt the view queries, the ETH call, RPC calls, that means that the users with the DApp that's running in their browser, they have an encrypted channel that goes directly to the smart contract that nobody in between can intercept or see what they're doing. And likewise, you also this wrapper also adds encryption to the estimate gas calls, because what you're trying to estimate, that leaks information about this. So we have a couple of different plugins. We've got the Sapphire Paratime plugin. This wraps window.ethereum, and you do like sapphire.wrap window.ethereum, and that gives you a wrapped Ethereum provider with the EIP 1193 that will automatically encrypt your transactions, your ETH calls, and your estimate gases. We also have the hard hat plugin, which, as you've seen, that will allow you to use encrypted transactions from hard hat. So the next question is, well, what can you do with Sapphire that you can't do with Ethereum? So we've shown transaction encryption. That means you basically have MEV protection for free, because the call data is encrypted. So that means nobody can snoop at the mempool and see that you're about to make a swap and sandwich attack you or something like that. But I think this is just the starting point. So what can we do that Ethereum can't beyond just MEV protection? So one of those is precompiles. So precompiles are essential for confidential EVM. Because the contracts are running in private, you can do things like having a cryptographically secure random number generator, and with that you could generate keys. You can even sign transactions, and we've added support for a good handful of different signing and key generation algorithms here. So ED25519, that's used on a variety of different chains. So we've got the P256R1. So that is used by a lot of the internet. Like if you want to sign an SSL certificate, the certificate authority is probably going to be using the NIST standard P256R1 curve. Then we also have the K1 curve, so that's the same curve that Ethereum and Bitcoin and lots of other cryptocurrencies use. So you can generate Ethereum wallets from inside a smart contract on Sapphire, and only the smart contract is going to know what the private key is, and the smart contract will only be able to sign it if it's built into the logic of the smart contract, and whatever authentication conditions you've put in there, the restrictions you've made into the contract, we also have P384, so we've got the NIST advanced standards, we've got top secret compatible standards that are used by Amazon and lots of other providers, which is the P384 curve. We also have encryption and decryption, so you can send encrypted data to a contract on Sapphire. The contract can decrypt it. It can also encrypt information, and of course, because we want to make this really easy to use, we're using a misuse-resistant authenticated encryption scheme. And of course, we have a variety of different hashing algorithms. So not just SHA-256 and the Ketchak hash, we also have SHA-384, SHA-512, and also the truncated version of SHA-512. And these are used in a variety of different places across industry. So if you want to take advantage of these precompiles from Sapphire, you need to add the Sapphire-contracts package into your project. Then in Solidity, you can import the sapphire.sol file, which allows you to use all of the Sapphire built-ins. So of course, we have documentation for this. So I go to the documentation right now. You can see I've got the random number generator. We go into the Sapphire contract here. Here's all the addresses of the precompiles, but we also have documentation on a function-by-function basis. So create random bytes. Generating a key pair for the curve 25519 curve. You can derive symmetric keys. That's using X25519. This is essential for deriving shared encryption keys between a public key and a private key. Good encryption, decryption, generating key pairs for all of the different algorithms we support, with signing, verification, and a couple of interesting functions around padding gas. So just a very quick interruption here, which is one of the side channels with confidential contracts is how much gas the contract uses. So when you send a transaction on Sapphire, you can see, if we look at any random transaction here, regardless of if it's encrypted or not, you can still see the from address, the to address, the amount of rows that was sent with it, the cost in gas, the gas price, and the amount of gas used. So specifically with the amount of gas used, if you're trying to keep things private, you need to be aware of, this could tell you, tell someone that's looking at the Block Explorer how, which code path the contract executed. So code path A may take, 34,000 gas if it's a successful guess. An unsuccessful guess could take 22,000 gas. And sometimes this can lead to some interesting problems with anonymity, with privacy, with security vulnerabilities. But we have some opcodes here to pad the gas. So that means no matter which code path your contract takes, you can pad it to the fixed amount of gas to obscure which specific code path was taken. So the next problem here is that in order to take advantage of these precompiles, they're only available on the Sapphire local net, testnet, and the Sapphire mainnet. And of course, it might be slow, and you have to request some, tokens and so on and so forth to deploy constantly on testnet, and it could be slow and annoying. So instead, we have the Sapphire local net container. So that's the entire Oasis Sapphire stack in a Docker container that you can run locally. So here's like a quick screenshot of it starts up. It does take about a minute to start up, but once it's running, it uses a low amount of CPU. You can keep it in the background, and then you can change your hard hat project to run against it. So, uh, if of course, if you're running on Apple ARM chips, you do have to add one more parameter here, which is to enable the Linux x86-64 emulation. Uh, but in our hard hat config, if I go here, if I want to create a Sapphire local net, I will go and change this here to local net. Let's change this to HTTP localhost 8545. Of course, we've got the private key here and the local. I can't remember what the local net network ID is. Here we go. So we've got a Sapphire local net. There we go. 0x5AFD. Put that in here. If I go back into my hard hat project here, I already have a local net instance running, which means I should be able to access it if I change the private key here. So the private key here, this is just one of the default accounts that we use for testing. That's oops. Apparently, oh, I didn't save that. So if I run that, and there we go. This is the 0xF39FD account. And this is all running on my Sapphire local net instance. So I've got my local net instance here, which this is running against. And of course, on local net, everything runs a little bit quicker. We've got instant block mining and so on and so forth, and it makes it really, really, really convenient for testing. So the next thing is, well, what can we make with Sapphire? You know, how do you think a little bit differently? How do you build with trust execution and Oasis? Well, I think one of the key points to get across is normally if you wanted to use trusted execution, you'd have to go and run servers from Amazon. You have to deploy a bunch of Linux things, maybe rent a dedicated server, and still you'd have to figure out how do we prove to other people that this is running in a confidential environment. Well, I guess what you get for free is if you deploy smart contracts on Oasis Sapphire, then we handle all of the verifications. So everything that is running on Sapphire, other people can verify that it's securely inside a trusted execution environment, and they know that nothing is going to leak out of the smart contracts, or at least they're not going to do anything that they haven't been programmed to do. So if we look at one of the first examples, if we wanted to make a loot box, right? We have a built-in random number generator. So if I wanted to, add an open loot box function to one of my NFTs, we load up the loot box. Of course, you have to verify that the person sending the transaction is the correct owner of the loot box. But then you can just use the built-in random number generator. So if we look at the take the random number generator results, modulo the number of choices in the loot box, and that gives you which item we're going to unlock for that user. You can then transfer that to whoever sent the transaction and destroy the loot box. So in comparison with other chains or like Chainlink VRF, this is all built into the smart contract platform. It's all available for free essentially, and it's instant. So you don't have to wait for callbacks. And this means that things like loot boxes are really, really easy. The only downside is you do have to be careful about, view functions and maybe like reverting transactions. So with this open loot box example, if I were to call the open loot box function, and if it didn't give me the thing that I wanted, I could just revert the transaction. That means that I could technically call it again and again and again until it gives me the right result. So for this reason, you do need to use like commit and reveal schemes. So you open a loot box, it would commit to a random number generator result. And then in the next block, where you're sure that the user can't tamper with this, you would then reveal what the result was and give the user the prize. So the next thing is about, well, what if you wanted to do a compliant privacy token? How could we encrypt ERC20 token transfers so that only a regulator could see the transfers? So with a lot of like privacy systems and ZK stuff, regulators are not really used to creating proofs and people proving that the source of funds was correct, and it still allows people to, for example, not provide a proof, and that could be a sign of guilt or a sign of just wanting privacy. So instead, if you wanted to do like a compliant ERC20 token, we could create a contract where you give it the encryption key for the regulator, and then on every single transfer event, you can encrypt the information. So in this case, the payload is know, who the origin is, who the destination is, and what the amount is. You encrypt this, and then you emit an event with the randomly generated number, and then the encrypted payload. So that means that somebody who's monitoring the smart contract, they can decrypt the events, they can see the information, but nobody else can, because uh, if an event is emitted on chain, anybody can see the events. But if the event contains encrypted information, then nobody can read what is in the encrypted information apart from the person that's it's encrypted for. So the other thing is, well, what about generating and signing Ethereum wallets? So we do have like a fairly comprehensive Solidity framework and an SDK suite that has like Ethereum utilities and an EIP 155 signer. So that means we have a single function for generating a key pair. So I can generate the public address along with a secret key. Now you might notice here, so the public address and the secret key, these are both public storage variables. That means that anybody is going to be able to see the public storage variable secret key. This is bad because this means that anybody can retrieve the key that only the contract should be able to access. So you should make the public key public, and you want to make the secret stuff that only the contract can see. You want to make this private or internal to the contract. So if we made the secret key private or internal, that means that only the contract would be able to access this, and it would only be able to use it within the trust execution environment. So here we have a very quick example where I can send in any transaction I want, and it will sign that transaction with the key pair. But of course, in a real world application, you'd want to start implementing your access control here. You'd want to restrict it to your own protocol. You'd want to define what kinds of transactions you want to encrypt, or maybe only encrypt them at certain times. But this is the kind of stuff that we're looking at here, where the contract can decide what to sign and what not to sign. So anyway, we started looking at cross-chain stuff, but we also have the Oasis privacy layer. So the Oasis privacy layer essentially is a way for using Oasis Sapphire and confidential smart contracts with contracts on other EVM-compatible chains. So this is like Polygon, Arbitrum, Ethereum, Optimism, etc., etc. And under the hood, we're using a message passing bridge, and we provide an easy to use framework that allows you to send messages from one of these other supported chains to Sapphire, or from Sapphire to one of these other supported chains. And the way that you do this for like a bidirectional bridge is we have OPL.sol, that's the Oasis privacy layer. You import that, and we have the Sapphire that exists on contract on the contract that exists on Sapphire, which is within the enclave. And when you create the contract, you're pairing it with a contract that exists on another chain. So we have the inputs here to the constructor, which is what is the address of the contract on the other chain, and which chain is it on. And then you start registering your endpoints. So the endpoints are functions that can be called from the contract on the other side. So I'm creating an example here. So secret example, I call the onExample function. We have to decode the argument. So I'm going to pass in a uint256 and a Boolean value, and then I'm going to do some confidential processing here, and then return it's a success. On the other side, I've got the home contract, which is a host, so it's not an enclave. I then pass in the address of my contract on Sapphire, so it's kind of implicit that if you deploy this contract on some other chain, the other contract is going to be on Sapphire. And I've got a function here, so I've got, again, my uint256 argument, my Boolean argument. I'm going to post a message to the secret example, and I'm going to encode these two parameters here. So you can see how this function here posts a message. Then this function, we've registered the endpoint with the secret example, and we receive the message and do the processing. But of course, there are other ways to think differently with the Oasis privacy layer and trust execution environments. So imagine if both sides of the contracts were running in trust execution environments. So both of those are running in TEs. That would allow you to have a secure link between both of the contracts. So just with the OPL example, where you give it the address of the contract on the remote chain, if you deploy both of the contracts within trust execution environments with and you give them like the encryption keys for the other chain with the other contract inside the TE, then they can encrypt messages for each other in a way that anybody can pass these messages across chain without being able to tamper with the encrypted message or alter it in any way. Unfortunately, most of the chains in the Ethereum ecosystem at the moment, they don't run in trust execution environments. So that means only one of the sides is going to be able to sign and make transactions. But you can still have a contract on the other side that is hard coded with a key from a contract in trust execution environment. So in this example, we have a notary function, a notary contract, where we generate a key pair, and I'm going to notarize something. So I'm going to say anything that I'm given in a transaction on the Sapphire chain, I'm going to sign it with the key pair that only the contract on Sapphire can sign for. And I'm going to return the signature for that data. So of course, in a real world application, you can start to put in your custom logic here, like restricting what can be signed, when can it be signed, who can it be signed by. But that means you can then have a contract on another chain that trusts this public address, and then you can use EC recover to verify that that the contract on Sapphire definitely did sign this, and that means you don't need a bridge on the other side, and you can interact with lots of other chains. So anyway, that's hopefully that should give you enough information to get you up to speed. We've got a lot of documentation. We have Discord. We also have Telegram, and we're going to be hanging around for the future of this hackathon to give you any assistance you need. So please check out the documentation. So we have the documentation for the contracts. We also have the Go code here if you want to dig deep into the runtime. We've got the SDKs here, so a lot of this is backend stuff. We've got the contracts, then we've got how to the various different NPM modules, so how to integrate with Ethers v6, do encryption with Veeam, WAGMI, with Hardhat, and then with EIP 1193 providers. Then we've got the full set of documentation here. So this goes into a lot of detail about how Oasis infrastructure, the Oasis privacy layer, how to deploy applications, how the workflow gets. We have a full example. Also have the Sapphire documentation here. So this is how to authenticate users, how to verify your contract deployments, how to submit gasless transactions, and how to do account extraction, various different ways of using proxies, and so on and so forth, and some really important security information, which will give you some background information of what to avoid. Then we've got the Explorer for both testnet and mainnet. And then we've got the faucet here. So if you ever need tokens to deploy on testnet, select Sapphire from the dropdown and request the tokens. So yeah, that's the end of the workshop today, and thank you very much for watching, and I hope this was helpful for you. And of course, If you need help, jump onto Discord or onto Telegram and get in touch with us, and we'll try to help you as much as we can.